This is the last lecture, web security. Web application in general refer to application on top on HTTPS. This is a typical setup of web applications involving a browser. So on the server side, we have the web server, and there could be some back-end server, for example, like the database server, the SQL server. On the other hand, on this side, on the client side, we have the browser, we have a machine. This machine has an OS, and on top of OS, there's a browser. It is the browser that interacts with the web services. And of course, we have the user. The user will browse the web page, click on URL. So the process of a web browsing starts with a user clicking on the browser. You make a click. For example, user click on a link, this link. The browser from this will generate a request, HTTP request, and send to the server. The server will have some back-end program that process the request and construct a reply. You construct a reply and send back. This reply is the form of a HTML format. You send a reply and send to the client site. The browser will then render the HTML page. You interpret the HTML page and find and render it, draw it on the display on the browser. Okay. The HTML page files describe the layout to be rendered and what to be presented. Okay. Cookies. There's something called cookies. Okay. So just now what I said, I haven't completed it. So when the user click, the browser will send the request. The browser may send some cookies, okay, across, okay, with a cookies if there's any. The server, after processing, when he sends the HTML page, this HTML page may come together with a cookies C1. And browser will store the cookies C1. Okay. We'll go to more detail later. Okay. And this HTML page could also contain program like script files. Okay. So then when the browser receives the HTML page, in rendering it, the process of rendering the HTML page may involve processing of some script files. So let me show you, give you some demo to show you in Firefox. Okay. Okay, so this is a browser. And the request, this request is sent to the Google server, and Google in turn send back a HTML page. What is the actual HTML page? You can do a right click here, look at page source. This is actually the HTML page sent back from the Google. The browser interpret this HTML page and render this page, okay, to be displayed to the user. You look at this this HTML page. There are many. You can see many terms like script. Okay. This actually specifies the start of a program. So this part is a script file. Okay, under way to the end. Okay, to the end. Okay. And you can also see more about the source, or even debug the source by using this part. you go to the tools and look at the web developer and toggle the web developing tools. Okay. So from here, we can see all the cookies in this web page. So now what if I type something here, let's say type CS2107. Okay. So remember that there is a script file running here. The script file will get this input from the user and then construct another request. When I press return, another request is constructed and sent to Google. And later on, Google in turn will process that instruction, that request, and send back this page. And you can look at the source. This is the actual source that is sent across. And this is the render page. Okay, let me switch back to the lecture notes. Okay, so this is just now what I mentioned. Okay, when we visit the Google page, okay, the HTML page will contain script files. So it's running. So when user enter these keywords, the script files will construct a query based on this keyword and send, and that query indeed is this one. Okay, you construct this query and send to the Google again. So in terms of security, okay, web security, this process is quite complicated and there's a lot of security issue. Okay, one of the issue is this, is that the browser. Let's look at these pictures. This browser, okay, in many OS, like for example using Windows or Mac, the browser is running with the privilege of the user. Okay, and it's the same privilege. So this browser can delete many files, any files, okay, the user files. Okay. This is not a case in the Android. Okay, mentioned later. Okay. And the browser, it support a very rich set of command, and then so in some sense, the browser now is more like the OS. It can run programs. It can support a rich set of commands to manage the user resources like files, users resource files. Okay. And browser also contain very sensitive user information. Okay. And to make things worse, at any one time, the many server is providing the content. Okay, so for example, in a typical browsing page, you see advertisement from different places. Okay. User, okay, in some case, user can also upload content to the server. Okay, like for example, the user can submit a post to the forums, and so this will create some problem also. Later we'll see it in the cross-site stripping. Okay. So in the PC desktop, okay, browser is in fact most of the time when you're using a PC, you're using a browser. Okay. And the browser have the same privilege as a user. The situation is slightly different in a mobile phone, where user use the web application through using apps. Okay, every apps is just one application. The threat model. Okay, we consider two threat model, model 1 and model 2. Okay, let's talk about this one. It's the easiest. Okay, so we have a browser and server, and they connected using HTTP. Okay, and potentially we can also use HTTPS HTTPS, in fact, is just HTTP on top on TLS. Let me have a HTTP protocol here. Remember the layering. We have a TLS and then all the layer. Okay. So all the packets, all the requests will be encrypted if we run TLS protocol. So like you may wonder, when this request is sent to Google, is this being encrypted by TLS? The answer is yes. Okay. So we also know that if we use TLS, we're using crypto, we can secure the communication. So even we have a man in the middle here, he's unable to compromise the confidentiality and integrity. Right. So we have a TLS. If we have man in the middle somewhere around here, then he's not able to compromise integrity and confidentiality. However, we have seen in quite some example due to implementation bug, TLS may have vulnerabilities, and from there, the man in the middle might be able to get more. For example, the freak attacks or the renegotiation attacks. Second threat model, okay, we assume this part is secure, okay, and the attacker is just another endpoint. That means that attacker could be a malicious client trying to interact with the victim server, or the attacker is a malicious server interacting with the clients. Okay. So example will be cross-site stripping attacks. Okay, vulnerability in the secure communication channel. So this is this setting. Okay. So we have, as I mentioned, we have seen some example like renegotiation attacks, freak attacks, or even superfish, or something that is not covered. Okay, these attacks that target as vulnerability or bug in the TLS. So this is another attack. You look at these pictures. Okay, while this is secure, sometimes this part, okay, the attacker try to exploit vulnerability in this part. Okay. How the user interact with the browser. So first one is misleading the user. First, URL. Okay, every resources in the web, okay, is defined by a URL, have a unique URL. The URL consists of these 5 parts. First is a scheme, it's whether it's HTTPS, HTTP, or something else. Okay. The host name, which is this part, host name. Okay. And the path, okay, path, query, and then fragment. So the whole URL is so long. Okay. And you may observe that, I don't know whether you have observed that in most web browser, when we display the URL, it's displayed using 2 intensity. You see, this is a boldface and this is a dark color. Right. So why is this so? Why is this so? Does it want to make it look nicer, or is a security features? In fact, it's a security features. Okay. Due to some security concern, the host name is shown in dark, is being highlighted. Okay. Why is this so? Because the whole URL here, there's no clear distinction of a host and the rest. the only way to distinguish it is to using this delimiter, this backslash. And a malicious website, okay, someone may, attacker may exploit this, so he may register for a website, for example, like this one. Okay. And this look like a stroke, and by first simple glance, user may mistaken that the host name is www.willy.cn, but in fact it's not. The host name is some 6678569.in. So the attacker may register for this host name and then put in his subdomain here. So and when this is displayed, this is very confusing. So how do they make use of this? For example, they in a phishing email, okay, they may send a link like that. User who look at this may not notice this and just click on it. And when this is displayed on the address bar, the user may not notice it and found that there is a padlock. Okay, if this HTTPS, there's a padlock. Then he may be misled that the connection is secure. The connection is secure, but it may be misled that is going to the right place. That's why you look at the many phishing email, for example, NUS phishing email, you ask you to click on this type of link. Okay, NUS login, which is try to mislead the user that you are going to any valid NUS website, but this part is belong to the malicious attacker. So Safari in Apple take even one step forward. It didn't even display the rest path. Only the path, only the domain name is, the host name is displayed in the address bar. Another attack is called address bar spoofing. The HTML in the page, okay, you want to display something, as just I demonstrate to you, this come from the raw HTML page, and then the browser interpret the HTML page, okay, even running some program, and this HTML page render this image to be displayed on the screen. In poorly designed browser may allow, okay, the program to display any image, for example, on any place they like. Okay, so this potentially malicious attacker may display an image to cover here. Okay, to display an image here and put in a padlock and put in any URL. Okay, so this is likewise achieve the same effect of misleading the user. Okay. So you may think that these are not common, but as recent as 2015, or 5 years ago, we still have this type of vulnerabilities. Cookies. What are cookies? When HTTP were first designed, it's supposed to be stateless. That means that if a user send a request one, a HTTP request one to a server, and subsequently submit another request, the server is not supposed to, does not keep the state of the first visit. So the second visit is as good as a new one. Later on, it turned out that this is very inconvenient, and thus the idea of cookies was introduced. To illustrate cookies, let's imagine the situation of buying fishball noodle in the canteen, arts canteen. So in arts canteen, We have this fishball noodle. Okay, fishball noodle. And when we visit them, first time we go there, we give them our option. There are many different options. For example, the option like you want to be mee pok, dried, and less spicy. Okay. After you state the option, okay, then next day, tomorrow, we go there again, and we have to state the same option. Mee pok, dry, less spicy. Okay. After a while, you may wonder the owner should recognize your face. It will be great that if we go to the second visit, we just have to appear there. Then the store owner will recognize our face and then give us the options. But the owner here is very busy. He's not able to remember everyone. So we can come up with a system of a token or cookies. When the let me see, when we first visit the store, okay, we mentioned that our option, okay, we told the owner our option, which is mee pok, dry, and then less spicy. The owner quickly take a piece of paper, wrote this down, okay, and pass back to us. Okay, this is the token. In fact, this is the cookies. Pass back to us, this piece of paper. So now we keep this piece of paper. Okay, in the next time when we visit the store, instead of repeating the order, we just pass this back to the owner, and then he read on it. Okay, then he know what's the order. Then later on, he can also write, update some information and pass it back to us. Okay. So now with that, the connection is no longer stateless. Okay, so we are able to maintain the state by using these cookies. Okay, so this cookie is passed around. When we visit the store, we pass the cookie to him. He can make some changes, then he pass it back to us. The next time we visit him, we pass the cookie to him. So that's it. Okay, so this is the cookies. So when the user click the browser, we visit this website, the browser would find any cookies, if any. Okay, if this is the first time we visit the website, there's no cookies. The second time or third time, there could be a cookies. So we pass the browser automatically send the cookie to the server. The user even didn't aware of this. Okay, so when the server send the reply, the server can send in the updated cookies C1, and this C1 will be stored in the browser for the next usage, next visits. So this cookie will store many informations. Okay, so you may have encountered this. Okay, when you go to a website, they start to ask you the consensus whether you allow a website to keep cookies. So why is this so? The EU, European Union, have a regulation called GDPR, General Data Protection Regulation, that required that the website should need to get the user consensus if the cookie contain traceable information. Okay. So the cookies is very useful. Okay, so just now I already demonstrated how we can see the cookies in the website. Okay, go to the get web developer tools and then go see look at the cookies. So now, who can access the cookies? Okay. So look at this website again. Okay. So suppose that this cookie is created by the fish noodle store, and next time when I visit the Indian food store, would my browser send the cookies created by a fish noodle store and send it to the Indian? Of course, this shouldn't be the case, right? Because there's a privacy involved. Okay, this cookie is created by the fishball noodle. We couldn't send to the Indian store. Indian store from there probably will know more about these two are in fact in some sense competitor. Okay. So when can we send a cookie to the server? Okay, this the browser use something called same origin policy, which is over here. Okay, and the same origin is what do you mean by same origin? If someone if the user visit a website, if the website is the origin of the creator of the cookies, then our browser will automatically send the cookie over. But what is the definition of the same origins? Okay. In HTTP is defined in this way. The origin is defined as a combination of the protocol like HTTP or HTTPS, host name, and the port number. So this seems to be simple. Okay, so as long as using the same protocol, same host name, and same port number, we consider the same origin, then we'll pass the cookie to him. But however, there are confusing definition on what is the same origins. For examples, HTTP, these two, okay, let's example. These two are actually in the same origin. They have the same protocol, domain name, and the port number usually is 80. And this part, okay, although they are different, they are considered same origins. And so likewise, same as this one. Okay, although over here you put in something like that. Okay. And these are different origin because this one is a port number is different. Okay, this using HTTPS. Okay, the domain name is different. Domain name is different. Domain name is different. But what about this one? Okay, the port number is 80. We specify 80 here, but here, because by default port number is 80, but this guy explicitly state it as 80. So should these two be considered same origins? Okay, it's unfortunately different browser use different interpretations. So it really depends on the implementation. And thus this may cause a lot of confusions and some vulnerability in the page. Okay. So the cookies are very useful. Okay, this is one example how cookies to be used. In fact, we have done this in our renegotiation attacks. Okay. Cookies is useful for this so-called single sign-on. Okay. So let's use this as examples. Okay. In this usage, okay, first time when the user visit the web page, okay, user want to log into this web page. So user will if user want to log into this web page, first the browser will send a challenge, right? A challenge for the password. The browser will display it and then ask the user to enter it. User have to enter the password here, and the password is sent across and browser verified. If it's correct, the server will send a so-called authentication token as a cookie to the browser, and browser will store the token here. Subsequently, when the user want to log in, now the browsers know that he have a token. The browser will immediately send the token over. And after the server receives the token, he knows that this guy is authentic. These two are the same. It's authentic. Then the server will not ask the user to log in again. By doing so, we save the user in logging in, the trouble of logging in. So that's why the name single sign-on. So like in the Facebook, when you first use Facebook using the new device, that's a new laptop, when you first time use the Facebook, you will be asked to log in. Okay. After login, a token is stored there. Subsequently, when you want to post a message in the Facebook or post something in the Instagram, then the server, the token will be automatically sent over. The server verify is correct, and the server doesn't ask the user to key in the password for Facebook or Instagram. Okay. So this is very convenient. But of course, now at this point of time, you know that the token is important, very sensitive informations. Also, the choice of how do we design a token is also important. Okay. The secure way of doing it is this. Okay, let's describe the insecure way. Okay. The cookie could be some meaningful informations concatenate with a sequence number. Okay, for example, like the cookies is Alice Tan. Okay, the Alice Tan have been logged in, and some informations, the date, and a sequence number 1, 2, 3, 4, 5, 6, 7, 8. And next time when someone being sent to a server for authentication, server will just check these informations to see whether Alice Tan is a valid user, the date is correct, and then this sequence number is for some maybe you know that the previous visit is the 128829, so you can read out the record of the previous visit. Okay, this type of meaningful message can sometimes can be predicted and guessed. So now, suppose that attacker want to impersonate Alice Tan. Okay, you know Alice Tan username, Alice Tan on Instagram or Facebook account, and then he can generate a token, okay, in this meaningful form and send to the server. The server might accept it, okay, with some presumably just a few exhaustive search on some numbers. So this is insecure versions because the adversary, okay, who can forge the token and send to the server and gain access. A secure version will be of this form. Okay. Likewise, we still have the Alice Tan and all the information required here. But this part is actually the MAC computed from this one. Okay, so we have this Alice Tan. We have all the information here. Okay. Then just go to the MAC, and then this come in here. Remember that MAC requires a secret key. What is this secret key? This secret key is owned by the server. Only the server knows the secret key. And because of this, that is very difficult for anyone to forge the MAC. So because they can't forge the MAC, they can't forge the cookies, the authentication token. Okay, cross-site stripping. Okay. What is a cross-site stripping? Okay. So in some website, okay, when this browser send something over, send a request, this a request, and the server will construct a HTML page, okay, and this HTML page is to be rendered in the browser. There are cases, or in fact, it's quite often, if the query contain a substring S. Suppose the sub S is a substring in Q. And somehow S will also be a substring somewhere in the HTML page. Okay. This has some implication. This means that potentially a person, a user, a malicious user, okay, can send something here and then will send back a HTML page containing this content. And because HTML page can be a program, then the browser will run this malicious program. That means that the attacker inject S, which could be a script, a program, a piece of program, and then this piece of script appear in the response and then execute in the browser. So let's give some examples. Let me share the screen. Share. Okay, this is a browser page. Likewise. So let's say that we put in something like www.com. Hello Kitty. Okay. Now we press return. You see that this is appear here. The kitty, whatever I put in here, will appear here. If we look at the source, okay, page source, the kitty, the string here also appear here. Okay, so this is a HTML page constructed by the server and sent back to the browser. Now, if instead of keying this garbage here, okay, what if we put in a program, a script file? We say open the script files, and would the script file appear here and causing the browser to execute the script file? So let's take one example. Let's say that we have a script. Okay, we start to run here. Okay, unfortunately, I cannot show the demo. Is that the browser have additional protections? He found that I'm putting a script file and then it's automatically block the access. Okay. So this attack will not work anymore. Okay. Previously, if you put in the script, then the browser will execute the script file. Let's go back to the lectures note. Okay. Like in this example here, okay, if we put in the script file, if it's not careful, if the browser is not careful, he may execute this script file. So these are attacks. Okay, so you may wonder why these are attacks. Why would this user, this attacker, send some malicious script to the server so that the server will inject, so that the reply contain the injected malicious script, and this malicious script is to be run in the attacker browser? Why would some attacker trying to attack himself? Okay, in fact, there's some cases like this. For example, the attacker trick a user to click on the URL, okay, which contain the malicious script. How does it treat? For example, writing a phishing email. There's this email being sent to the victim, and this email have a link, and here it's called click me. Okay. In this click me, it contains this malicious script. So then the request will be sent. Okay, so this click me request sent to a target server, and then he will send back here. Then he will run the script in the victim. So this is a victim. Okay, the attacker the malicious attacker generate this email, okay, and the victim click on it. Okay. So now the malicious script is run on the victim browser. Okay. What could the malicious script do? First, one thing, he may be very harmless. He just deface the original web page instead of displaying so that's called a deface web page defacement. Okay, but a more serious one is that he may steal cookies. Why he can steal cookies? Now you look at this. The scripts, when the victim click on this, you go to this targeted website, and the targeted website will send back the cookies, and put in here. And the script, malicious script running here, has access to these cookies. Okay. So now, okay, coming from the same place, so it can, the malicious script can get the cookies. So this type of attacks is called cross-site stripping, XSS. There are two types. First type is called non-persistent, which is what we have described here. The script appear in the URL sent to the server. The server reply with the HTML page, and HTML page contain the injected script. The other part, the second type is called persistent. So what is this? So imagine that we are using Luminous, and any user, the user on Luminous can submit a post to the forum page. You can submit a post. This is a forum page. Okay, and there's a subject. And blah, blah, blah. Okay, so we can, as a user, we can submit a post, and this post will appear in the forum page. So now, assuming that there's some variability in this, attacker, when he key in his post, instead of typing the post, he put in somehow he can put in the script that he put in the script as the post actually contain the words scripts. Okay, or it could be even the title. Okay, or even names. Okay, suppose you are allowed to say the names, or uploading some files as an attachment. Okay, so all this information will be stored in the web server. Then the victim come here. The victim is another user. Who view this web page, this forum page. Okay. So in this case, the script file, the malicious script, is persistent, is stored in the web server, so that anyone who come here will retrieve the injected script. This is different from the reflection, where it's not persistent. The defense mechanism, okay, is carried out in the server side. That means the server filter out, have some input validation to filter out the script files. However, this is not a foolproof method. There's another type of cross-site scripting is called cross-site CSRF, cross-site request forgery, pronounced as CSRF. So in this case, suppose the scenario is that the client is already been authenticated, okay, and the server, okay, keep some cookies, okay, like the token. So you can imagine that Alice is using a browser, and he has already been authenticated. Okay, authenticated. the attacker trick A to Alice to click on the likewise send a phishing email to Alice and trick A to click on this this link. This link is giving an instruction to the bank to transfer the amount to Bob. This amount to Bob. Okay, this is HTTPS. Now, when Alice clicked on this link, as we mentioned before, this is a single sign-on. This, together with the token, will be sent to the server. Okay. Then the server look at the token is valid, and then will execute this command. So in this case, this attack actually exploit the server trust of the client. Previous one exploit the client trust of the server. How to defend this? This is relatively easy, but you need to train the programs, application programs. So in the server, okay, the server, when he receive a request together with token, the server, the authentication information need to be explicitly in the request itself, beside the token. So we have the token information here plus the original token. So the authentication information has to be in the request. Then this attack can be prevented. Why is can be prevented? The attacker, when he sends this phishing email, of course the attacker doesn't know what are these informations. There are many types of other attacks of a web server, web security. Okay, they look like drive-by download, a web bug, okay, click jacking, okay, CAPTCHA and click faults. Okay, what is click faults? This is something very interesting. I think a lot of students doesn't aware of this. Is that how much when we visit a website and we saw advertisement, we click on the advertisement, then this is called pay-per-click. The host of the website will get some monetary award from the merchant. Okay. So it will actually is quite expensive. You can gain about even $1 per click. So there is a lot of farm, okay, who click for themselves. They will click on their own website. Okay, they go to their own website, click on all the advertisement. Okay, so this is called the click farm. Okay, the click farm. Okay, do that. Okay, with that, okay, and the lectures. Okay, next week I will also upload lectures which give an overview, a very short lecture on the overview of what we have done.